Hi everyone. Most of you will know that I've been working on the Blender Game Engine Python API for some time now, and part of that project has been working on the collision callback system that I've implemented. I've noticed that in the Blender Game Engine we don't have access to the collision information other than the fact that a collision has occurred, and that gives us a little bit of limited prospects for working with collisions. So in order to combat this, I've actually written a patch which allows you to read the hit points and other data of every collision. Now to demonstrate this, I've got a very simple example. It's simply a bullet colliding with a wall, and if I stop the game and hit the bullet, it will then spawn these particles, which is what the red spheres represent. Now that's always been achievable in some context, because we could spawn the particles at the bullet, or we could do a raycast into the wall. But raycasting is only really useful when you know the shape of the object when it hits the wall. So if you had a very complex geometry, and you wanted to work out where it might touch the wall, you'd have to raycast quite frequently, and that's quite expensive and a waste of resources. So here we have the ability to do a little bit more complex stuff without necessarily complicating how we do things. So here's my bullet, and if I grab it to the left, if we were using the previous example of raycasting from the object center, or by using the object center directly, we would expect the bullets to spawn to the right, in this case. Likewise, if we were to do some complex, or rather, we could also do some complex vertice weighting, so summing all of the vertex positions to find out the center of mass here. But again, that's complex, and most users won't want to do that. So if we then try this out after having moved the center, you'll see that it still spawns bang on where it should do. And one last example to demonstrate how effective this is: if I duplicate this and grab it to the right, switch back to layer 1, and then zoom in and press space, you'll see that we spawn 2 pairs of bullets, because we're just using the contact points and nothing more. What does this give you? What functionality do you gain from this? Well, at present this is exposed in 2 forms. The collision callbacks, which I had already implemented, will receive a new argument called data, well, it's not called anything, but you may call it data, and that is a list of collision contact points. Each of those contact points is a class. It's a special type of class called the KX_collision contact pair, and that has the following attributes. It has the position, the normal, the impulse, the force, and the position other. Now, the hit position other is the only attribute that doesn't really make any logical sense, and that basically refers to how bullet determines the collision point. One point is the actual collision point on the mesh, and the other one is the nearest point to that point on the other mesh. And there's no real need for it for most users, but it's good to have it exposed in case people do decide to use it. Another thing that's important to consider is that because these contact pairs are created for every collision on the mesh, and maybe more than one collision per frame, especially if it's intersecting the wall, to work out the actual force of the entire collision, it's best to take the average of all of the hit forces, and likewise the average impulse, by summing all the hit impulses and then divide it by the total. So that's something to consider there. And this data is also exposed on the sensors. So if you have a sensor with a hit contacts attribute now, and you can read the contacts off that. So that's what I've done in my example here. If I show you the code window, you'll see that I've got sensor.hit contacts, and for each contact, this code is irrelevant here. For each contact, I'm generating 20 bullets or 20 particles, and I'm moving them around in their linear velocity based off the hit normal as a random number. So that's all for today. Thank you for watching, and I'm going to try and get this into trunk as soon as possible.